We're going to show you some extraordinary images of space, 400 ultra high definition television screens, because each one contains 3,200 megapixels.
Trying to snap a photo of the entire Milky Way might sound easy. Just point a camera and click, right? But the truth is, it's way more complicated. Why? Because we're stuck inside it. It's like trying to take a group photo when you're standing in the middle of the crowd. You simply can't see the whole thing. Even if we somehow launched a spaceship to fly far enough away to get the full shot, we'd have another problem: distance. The Milky Way stretches over 100,000 light-years across. That's so far, it would take billions of years just to reach a spot where we could take that picture. So instead of one impossible snapshot, scientists came up with a smarter approach: map it, bit by bit. Using high-powered telescopes, they scan the sky, collect data from millions of stars and cosmic objects, and stitch everything together into one detailed image of our galaxy. And what you're looking at right now, that's the result of that epic effort. It's the most accurate map of the Milky Way ever made. This masterpiece was created using a jaw-dropping 3 trillion measurements of 2 billion stars and cosmic bodies, all collected over 11 years by the European Space Agency's Gaia mission. For more than a decade, Gaia has been quietly sweeping the sky, giving us views of the Milky Way like we've never seen before, both top-down and edge-on. The clarity is breathtaking. But Gaia didn't just make a pretty picture. It uncovered secrets, deep, game-changing truths about our galaxy that we never knew. Gaia might not have the celebrity status of Hubble or James Webb, but in the world of astronomy, it's made waves, huge ones. Scientists say its findings have hit the field like a tsunami, completely reshaping what we know about the Milky Way's shape, makeup, and history. So next time you look up at the stars, remember, we're finally beginning to understand the vast galaxy we call home. And it's thanks to a mission that dared to see the invisible, one star at a time. But Gaia's journey didn't start from scratch. Its roots go back to the Hipparcos mission, the first time humanity ever tried mapping the stars from space. Back then, Hipparcos charted about 120,000 stars. That was groundbreaking at the time. Then came Gaia, and it changed the game completely. Gaia set out with a bold mission to map nearly 1 billion stars. That's around 1% of all the stars in the Milky Way. Sounds small, but in the cosmic scale, it's massive. The spacecraft launched in December 2013 with a budget of around $1 billion and headed out to a special spot in space called the Earth-Sun L2 about 1 million miles from Earth, the same neighborhood as the James Webb Space Telescope. But here's where Gaia stands apart. Its precision is almost unbelievable. Imagine trying to measure the width of a human hair from 600 miles away. That's the level of accuracy Gaia brings to the table. It's not just a telescope, it's a finely tuned machine built to map our galaxy like never before. At the heart of Gaia are 2 identical telescopes, angled 106.5 degrees apart. This clever setup lets Gaia catch each star from 2 different perspectives as it slowly spins in space. Light from these stars is funneled through a complex system of mirrors and into Gaia's powerful camera, packed with 106 CCD sensors and nearly 1 billion pixels. Yeah, billion, with a B. Here's how it works. When a star enters Gaia's view, it first passes through a set of sensors that track its exact position in the sky. These astrometric CCDs are so precise they can spot even the tiniest movement of a star over time. By observing a star multiple times, Gaia can detect its parallax, the tiny wiggle in its position caused by Earth's orbit around the Sun. That wiggle tells us how far away the star is. Next, that same star passes through another set of sensors. These ones break its light into different colors, kind of like a rainbow. This helps scientists figure out the star's temperature, brightness, size, and even its chemical makeup. And finally, for some stars, Gaia sends their light through a special instrument called a radial velocity spectrometer. This tool splits the light even further to reveal whether the star is moving toward us or away, just like how a passing siren changes pitch as it zooms by. That's the magic of Gaia. Every piece of light it captures turns into data that lets us measure, map, and understand our galaxy in a way no one ever could before. And that's just the beginning. Most telescopes work by locking onto one target at a time. Not Gaia. Gaia does things differently and brilliantly. Instead of staring at a single point in space, Gaia is constantly rotating, sweeping its twin telescopes across the entire sky in slow, steady motion. That means every star isn't just seen once, it's observed over and over again, from different angles and at different times. The result? One of the most detailed, dynamic 3D maps of our galaxy ever created. And the numbers? They're mind-blowing. Gaia scans more than 2 million stars every hour, and it sends back over 50 gigabytes of data every single day. All of that gets transmitted to Earth, where it's analyzed and stitched together like a cosmic puzzle. But here's the really incredible part. Gaia doesn't just capture where stars are, it captures where they're going. Each star is on its own personal journey, moving across the sky in what's called proper motion, and Gaia tracks that motion with breathtaking precision. Thanks to these repeated observations, scientists can now do something that once seemed like science fiction. They can rewind time to see how stars moved in the past, or fast forward to watch how the Milky Way will shift and evolve far into the future. Even constellations, the ones we've all grown up seeing as fixed shapes in the night sky, aren't so fixed after all. Over thousands of years, they stretch, bend, and morph into completely new patterns. But it gets deeper. The stars' movements aren't just about where they're heading, they also reflect our journey. The motion of stars around us helps reveal something much bigger, the path of our solar system as it orbits the center of the Milky Way. Gaia can even show this galactic dance in action. By analyzing how nearby stars, within about 1,000 parsecs, move relative to us, we can see the graceful curved orbit our Sun traces through the galaxy. And when we combine Gaia's super-accurate measurements of distance, speed, and direction, we can create stunning 3D models of how stars move in space. Not just dots on a sky chart, but living, flowing motion. Want to see it in action? Look at this animation of 74,000 stars within 100 parsecs of Earth. Some stars drift inward, others shoot outward toward the galaxy's edges. Most swirl along stable, circular paths across the galactic plane, shown in shimmering purples. But some take a wilder ride, soaring above or dipping below the disk, glowing in yellows and reds, like cosmic rebels. It's not just a map, it's a time machine, a living, breathing portrait of our galaxy in motion. And we're right in the middle of it. Thanks to Gaia, we now have the most breathtaking crystal-clear view of our home galaxy, and it's completely changed what we thought we knew about the Milky Way. For years, astronomers believed our galaxy had two main spiral arms, maybe a few smaller ones branching off. That was the model we learned in textbooks. But Gaia's data told a very different and much more fascinating story. It turns out the Milky Way is a lot more complex. Those spiral arms, there are more than we imagined. They're faint, tangled, and beautifully intricate. Nothing like the neat, simple diagrams we used to rely on. Gaia's face-on view of the Milky Way is absolutely stunning. Picture it, a glowing golden center, like a cosmic lantern, with graceful spiral arms swirling outward in near-perfect symmetry. It's the kind of view we could only dream of before, like looking down on the galaxy from above. And then there's the edge-on view. Against the pitch black of space, the galaxy appears as a slim, dark brown disk that stretches across the frame. It looks razor-thin at first, but look closer, and you'll notice something odd. It bends, it curves. That's because the Milky Way isn't flat. It's warped, and that warp, it's not just sitting there. It moves. Think of a spinning top that starts to wobble. That's what our galaxy is doing. But here's the kicker. It's wobbling faster than scientists expected, which hints at some mysterious force behind it. Something we don't fully understand yet, may be shaping the very structure of our galaxy. And then came one of Gaia's most unexpected discoveries, the Radcliffe Wave. Imagine a gigantic wave of gas stretching over 9,000 light-years across space. It cuts through our very own Orion arm, the same arm our solar system calls home. This wave makes up a whopping 40% of the arm's length and sits anywhere from 400 to 5,000 light-years from us. Before Gaia's high-precision 3D mapping, the Radcliffe Wave was completely hidden. All we saw were random, scattered regions where new stars were forming. No one had any idea they were all connected, part of one massive, undulating structure rippling through the galaxy. But Gaia revealed it, like pulling back the curtain on a secret hidden in plain sight. And this is just the beginning. Every discovery Gaia makes opens the door to new questions, deeper mysteries, and a growing sense that the Milky Way is far more alive, dynamic, and awe-inspiring than we ever imagined. So here's something wild. The Radcliffe Wave, this massive wavy ribbon of gas, is now known to be the largest continuous gaseous structure in the entire Milky Way. How big? Try 3 million times the mass of the Sun, just in gas. That's the kind of material that stars are born from. And it turns out this wave plays a major role in fueling star formation in our corner of the galaxy. Even crazier, our own Sun is riding right alongside it. At one point, just 500 light-years away. It's almost like our solar system is catching a cosmic wave. And here's where it gets even more interesting. Based on current models, the Sun actually passed through the Radcliffe Wave about 13 million years ago, and it's expected to surf through it again in the future. But what created such a massive galactic ripple in the first place? That's still a mystery. One theory suggests a collision with a smaller galaxy may have stirred up the gas, creating the wave's dramatic shape. But to know for sure, we'll need even more precise data from Gaia. And speaking of galactic collisions, Gaia has also helped scientists uncover something incredible, a series of crashes that may have directly influenced the birth of our solar system. Enter the Sagittarius dwarf galaxy, a much smaller companion to the Milky Way, discovered in the 1990s. Compared to our galaxy, it's tiny, just tens of millions of stars versus our hundreds of billions. But what it lacks in size, it makes up for in impact. Over the past few billion years, Sagittarius has smashed through the Milky Way's disk at least 3 times, about 6, 2, and 1 billion years ago. And every time it collided, the Milky Way pulled stars away from it, slowly tearing it apart. Eventually, Sagittarius will be completely absorbed by our galaxy. But even as it's being devoured, it's shaping the Milky Way in big ways. In fact, researchers in 2020 found that each collision triggered waves of star formation, like a rock dropped into water creating ripples. These galactic ripples compressed massive clouds of gas and dust, prime ingredients for building new stars. And here's the jaw-dropper. One of those collisions happened around 4.7 billion years ago, right around the time our Sun and solar system were forming. A separate study in 2019 also revealed that before these cosmic crashes, star formation in the Milky Way was actually slowing down. So, in a very real way, our solar system might not even exist, if it weren't for a tiny galaxy crashing into ours at just the right time. About 5 billion years ago, something unexpected happened in our galaxy. Out of nowhere, the rate of star formation exploded. Nearly half of the stars we now see in the Milky Way's thin disk, the flat region where most stars are born, were formed during this cosmic growth spurt. So, what triggered this sudden burst of activity? Well, scientists believe it was the result of Sagittarius, that small neighboring galaxy, smashing into the Milky Way. Without that impact, our galaxy might have looked a lot dimmer, less populated, and frankly, less alive. That one collision may have changed everything. Thanks to Gaia's ultra-precise measurements, we now have a time machine of sorts, a detailed history of how the Milky Way evolved, and it shows us something powerful. Even the smallest cosmic events can have massive consequences. But Gaia's mission didn't stop with just mapping our galaxy. It's been a game changer across almost every corner of space science, tracking asteroids, discovering hidden black holes, and even helping spot planets orbiting distant stars. Take asteroids, for example. Gaia has charted the orbits of more than 150,000 of them, painting the clearest picture yet of the inner solar system's structure. One stunning visualization shows their swirling orbits, each color-coded by region: yellow for the Sun, blue for the inner planets, green for the asteroid belt between Mars and Jupiter, and red for the Jupiter-Trojan asteroids, way out near Jupiter's orbit. But here's something truly unexpected. Gaia also uncovered signs of moons orbiting asteroids, around 350 of them. How? By detecting subtle wobbles in their movements. A lone asteroid moves in a smooth arc, but if it has a tiny moon, its motion shifts slightly. Again and again, a small rhythmic dance only Gaia's instruments could pick up. And it doesn't stop there. Gaia has also helped locate what scientists call sleeping black holes, massive objects that don't give off any light, making them nearly impossible to find. They just sit there, invisible, pulling on nearby stars with their gravity. But Gaia's precision allowed astronomers to spot their quiet influence, like noticing a ripple in a pond and realizing something enormous is lurking just beneath the surface. Most of us think of black holes as these terrifying cosmic vacuums, sucking in everything around them and glowing with wild, high-energy radiation. But not all black holes act that way. Some are completely silent. They don't feed on nearby matter. They don't shine. They just sit in the darkness, invisible to even our most powerful telescopes. That's where Gaia comes in. Instead of looking for light, Gaia looks for movement, the tiniest wobbles in stars. And those subtle shakes can only mean one thing: something big and unseen is pulling on them. That's how Gaia discovered a brand new class of stealth black holes. So far, it's confirmed 3 of them: Gaia B, H1, BH2, and BH3. But it's BH3 that really grabs attention. It's not only the biggest of the trio, it's also the most massive stellar origin black hole ever found in the Milky Way, 33 times the mass of our Sun. And here's the crazy part: it's not some distant mystery. It's hanging out just 2,000 light-years away in the constellation Aquila. But Gaia's not done shaking things up. Recently, it uncovered 2 unusual celestial neighbors: a super-Jupiter exoplanet named Gaia 4b, located about 244 light-years from Earth, and a brown dwarf called Gaia 5b, sitting around 134 light-years away. What makes these discoveries so thrilling? Well, Gaia didn't spot them the usual way, by seeing them directly or watching them pass in front of their stars. Instead, it detected the tiny gravitational tug they exert on their host stars. A cosmic wobble, once again, tipped Gaia off. It's a major first. Gaia 4b is the first planet ever discovered this way, using Gaia's motion data alone. And it's no ordinary planet either. Gaia 4b is nearly 12 times heavier than Jupiter, making it one of the most massive planets we've ever seen, orbiting a small star. It's so big, it's sitting right on the edge of being a brown dwarf itself, a total oddball, a giant among giants. Now let's talk about Gaia 5b, a brown dwarf that's stirring up just as much curiosity. Like Gaia 4b, it orbits a low-mass star, and that pairing, it's incredibly rare. Brown dwarfs aren't quite stars, and they aren't quite planets either. There's something in between, and finding one in a setup like this is like spotting a unicorn in space. These discoveries are more than just cosmic fun facts. They're proof that Gaia is unlocking a new era of space exploration, helping us discover not just stars and galaxies, but strange, rare worlds we didn't even know existed. And here's the exciting part. Gaia's mission isn't done yet. While the spacecraft has already wrapped up its sky-scanning duties, the real treasure hunt is still happening back here on Earth. Scientists are still combing through mountains of data, and there's more coming. 2 major data releases are on the horizon, one in 2026 and another in 2030. These new releases will fine-tune everything we've seen so far, sharpening the picture, filling in the gaps, and revealing details of the Milky Way we've never seen before. Every byte of data Gaia sends back helps bring our galaxy into clearer focus. It's like going from a blurry old photo to a 4K, full-color map of our cosmic neighborhood. We're not just learning about where we live, we're finally starting to understand it. So stay curious, stay tuned, and keep looking up, because the universe is full of surprises, and Gaia's just getting started.